introduction to begin with, and then we can off with the discussion. Can you see my slides? Okay. Okay.
Yes.
So yeah, thanks everyone for hopping on to this call today. So CARC is Campus Research Computing Consortium, and it's basically for all the folks who are involved in research computing and data. So all the professionals in different capabilities involved in this area are welcome in this community. And CARC is spread into different types of tracks or groups. So People Network is the main track where it's a year-long conference that happens. There are several tracks under People Network. And then there are different working groups where specific aspects of RCD are discussed. Interest groups are something that we have been, people get together to talk about um, staff workforce or student workforce development and so on. And then there's the support group, the ops group, which supports CARC activities. So the People Network is a network with different tracks. So there's a data-facing track, mostly focused on people who are interested in data management and as such. Emerging centers is for people who have smaller institutes, smaller footprint in the RCD and growing, or anyone developing that, or your center is developing. So that's your track to go to. Researcher facing is if you do facilitation, consulting, outreach, those kind of discussions happen in that track. System facing is actual hardware of the system and provisioning, engineering, security, and so on. And then strategy is leadership associated with RCD and challenges associated with that. So that's what we discuss in strategy and policy facing track. So for our track, so if you want to get involved with CARC, there's the easiest thing to do is to join the mailing list and start attending the events. So the links are posted in these slides. We'll post the slides to our website afterwards, and also we'll have the video recording available at the end of the call, posted on our YouTube channel, CARC YouTube channel. You can get started. To get started, you can just send an email to get started at CARC, or you can also go to carc.org and how to join to get involved with the People Network tracks. Basically, the idea is just come to the track, attend the tracks, get involved in the discussions. Once you find that it's useful, if you have some spare time, think about joining the track steering committee. So, and again, this is call for people to volunteer to join the strategy and policy facing track steering committee. And once you're on steering committee, you can become a track coordinator. So current members of the steering committee are listed over here. And we are always looking for more steering committee members who help develop the agenda for the upcoming meetings and take the understandings or collect all the information that we gather in these meetings and in these calls, and potentially present that at conferences like PERC and so on. So that's kind of what the steering committee does. So we are always looking for more steering committee members. So if you are interested, just send a note to me or Patrick or anyone on the committee there. Now, next month, we are going to cover CASC meeting and CNI meeting recaps. So these meetings are happening in March. So that CASC is actually next week and CNI is latter half of the month. So these two meetings, we'll have people who have attended that meeting come and talk with us. Sometimes we cannot attend these meetings, so it's useful to have that discussion. So we'll continue to have this ongoing discussion about key RCD conferences and meetings in this track. And then for today's topic, we are going to talk about strategy and policy challenges in supporting large language models for research. So some aspect of how generative AI is used in research, and then majority of the focus would be how we are supporting generative AI. What are the challenges associated with supporting that? Like how do we create the infrastructure? What are the policies associated with that? So how people are looking at return on investment in this area. So this is going to be like an open discussion. Um, we have invited Alex Feltus, who is faculty at Clemson, to kick off the discussion, as he is deeply involved in large language models for research, not only at his institute, but also he has his own company. So I'll start off with Alex talking a bit about this, and then we can continue with the open discussion. So I'm going to stop the screen share and then switch to the open discussion. And Alex, if you have slides, just let us know. I'll just open discussion is fine too.
Yeah, let's try open discussion. I have some slides if we need to do it. So I might be a bit of a square peg in a round hole with your intentions for this. We'll see. But it's just my background. So I'm a Clemson professor. I've been professor for a long time. So I was always thinking like, I think I know exactly how many years I've been married. I think I know exactly how many years I've been a professor. I'm not exactly sure. It's been a lot. Happily married, by the way. I guess I should say that since this is being recorded. But so I'm an end user. Well, I mean, I'm a computational biologist. We do a lot of work in intellectual disability genetics. We're doing a lot of ancient DNA, admixture genetics, and trying to understand phenotypes that could have come from ancient humans, not modern humans. I do a lot of work in agricultural genomics too. I've done a lot of work in the past in bioenergy, genetics, trying to build better crops for making ethanol and other feedstocks for other things. Everything I do is big data stuff. For the last, since I saw or turned on the human or used the human genome in 2001, it's been, my computer's never big enough since that point. And so I used to do a lot of work. I do a lot of, faculty engagement, or have in the past at Clemson with our supercomputer campus cluster. I've been on the board of Internet 2, trying to help out with, moving data around, large data sets, everything. So anyway, so I'm into data, right? And so one of the biggest problems, so let me put my hat, I'm a scientist researcher hat, and I'm trying to do genetics in humans and plants. And so one of the biggest problems I have is the data is out there is unbelievable. Like I don't focus on one field. I do lots of different things. So it's impossible, no matter how much I didn't sleep or how hard I tried, I would never be able to keep up with the literature. I can't keep up with the data we generate. Like we're dealing with 60,000 dimensional data, looking at human phenotypes and stuff like that. So like my brain isn't big enough, and never will be, to handle this stuff. And so I've been using AI for really pre-COVID. We started using generative AI through GANs to try to simulate state transitions between like normal and tumor. And so I have computer engineers, computer scientists, geneticists in my lab, and we all work together and try to solve these problems. And so AI has been really kind of cracked open, like punched that first hole in the cave. I can see a little bit of light coming in a few years ago, to be able to deal with these data sets, right? And the statistical models, they just fall apart and all this kind of stuff. But then like in 2020, is it 2022, I guess, when Chat GPT got turned online, we immediately started trying to, ask like everybody else, ask any questions and biological questions, stuff like that. In my company, I have a company called Praxis AI. We do a lot of digital education. We have labs baked into our experiential learning platform and all that kind of stuff. It sits on top of Canvas and all this kind of stuff. We started building an AI assistant, right? It started just a Chat GPT bot, and that got us about 40% there. And 40 is like if you fail your exam. If you get a 40, I need to have really good answers. So we started doing some back end prompt engineering and other methods to validate the answers. To now we use Chat GPT for really kind of as a language engine for responses, but we actually get a lot of our information from other sources besides the large language model. So this is the square peg in the round hole. I'm an end user of large language models that have been modified to meet my needs. And my needs are met to the point where the co-instructor, which can be personalized for different people, different professors and stuff, is my co-instructor in my class. So my classes now are half AI, half HI, human intelligence, and so the students have access to this all the time. Is baked into our learning platform, right? And so I'm drawing from large language models. We have the ability to take a compendium of information through a collaboration we have with AWS to be able to put a focus compendium, 100 papers on a particular topic, like we're looking at some rare diseases, to be able to ask questions from that information, and then also be able to go out into our other sources, right, through our large language models. So my hat is the teacher or scientist using AI tools, generative AI tools, to be able to do research and teaching. And to me, like, teaching and research don't need to be separate things. Like in my classes, they're all doing projects, and we're making bioarchive papers and trying to find patterns of data. So instead of like waiting like to teach people for 8 years and then they go learn how to do research, I just start from square one, even at the high school level. So I'm an end user, but I have a lot of tech knowledge. I can't talk too much about this because I don't really know a lot of the requirements. But like we have proposals pending from Clemson to upgrade our GPU capacity on our campus cluster to be able to build large language models. I haven't done that in my lab, so I don't know how hard it's going to be. But I do know that some of the people that have dabbled in that, it sucks up your resources pretty quick to be able to do that. So that's kind of like a phase. Another next phase for me is to build my own large language model, and maybe I have enough money to do it in the cloud, or have to do it on some other method. That's my intro.
So I guess thanks, Alex, for the intro. My questions, I guess, my initial thought was like, since you use large language model in practice, like you probably trained it and then deployed it. So while training, you probably need a lot more resources than actually inference. Or
I have not built a large language model. So I
oh,
only
you
use
haven't,
existing large language models.
not yet.
Yeah.
Okay.
That's why I'm saying the square peg round hole.
Okay.
So I'm not doing the computer science, but I'm an end user. I'm a researcher. And I'm a big believer that, the researchers are important too, of, end using and not just generating new algorithms, and we're actually using the algorithms to generate new knowledge in our fields.
So what level of resources, do you find you need, Alex? And especially since, you're working with a lot of people with some of the tools you've built, what are you telling people in terms of what do they need to expect to have to be able to effectively use the tools that you're building?
So just through my company, the way our Priya is the one version of the AI assistant that we have, and like she's like a associate professor level type knowledge engine. But so we're using our back end systems to be able to give proper answers, and there's no hallucinations or anything like that. We fixed all that. And we're deploying that. It's actually being piloted at lots of universities. I don't know, maybe some of the ones on this call. But it's a credit-based system, and so you can, it costs money to run this. All run in AWS, and so we have a credit system. Like we bake it into the textbook fee in my class, and I don't make any money off of it. I just get a cost with my students, transparency with the university and everything. But so it's a cost thing for actually asking questions, right? And we have a credit system, and the students ask a lot of questions. So we have detailed numbers, but it doesn't run out pretty quick. We're able to keep it at a minimal cost. But that's where, if we wanted to build our own large language model, I'm going to have to go out and go talk to VCs, right, to get the money to be able to build it. So I like the idea of like open source large language models appearing all over the place, especially for bioinformatics and genetics and stuff like that, and leveraging those.
All right. I guess I don't see Rich Nepper on the call. Is he on the call? No, sorry. Recently, Cornell came out with a report on how they are working with how generative AI how do we tackle generative AI in general? So generative AI for research. And maybe I'll throw in the link in the chat. He was supposed to come and give us a brief overview of how they have how they are going to tackle generative AI. Ashley, go ahead. You had a question, so.
Yeah, sure. So I just put in the chat a link to a podcast I just actually listened to on my way home from Nashville this past weekend. And the speaker speaks about like when and how to build an AI program. Like what are all the things that you should consider when building an AI program? So there is a lot of good, useful information in that. And I'm thinking about a data program. We're not anywhere close to AI program. Yeah, and so I'm primarily in research administration these days. But one of the considerations that they mentioned was cost and how expensive it potentially could be to try to deploy a large language model like for your own business or for research. And Alex, I'm wondering if you have any experience with this or thoughts about that, you know, from the researcher perspective.
So, so if a researcher and a teacher perspective, right? Because I use it in my classroom as a co-instructor, but I'm using it in my lab too for research purposes. But so, you know, we have not even close to tapping out, like just leveraging Chat GPT models to be able to do a lot of our language organization and building side models like satellite models that we're doing with a RAG approach with AWS, where we can upload a compendium information and be able to go into it. So there is no need for me in the foreseeable future as a businessman or as a researcher to build a large language model. I can access the ones that I have. And from a genetics perspective, I'm really excited about some of these models that are starting to emerge where I can just tap into those. So I'm more interested in like trying to understand why this kid's got seizures and find the genes that are involved, like biology stuff, right? Then building a large language model, then one day figure it out because I'm making so much progress with it. So the cost is on being able to pay OpenAI, you know, and other third parties to do this. And you can't just, you know, ask the students to then all of a sudden, you know, if you had to pay for Google search, like having your university say, okay, well, everybody go use Google and then have the kids pay for it. And like, you know, there's a lot of kids struggling, right, to even survive and eat, let alone pay for yet another thing. So we're baking that all into the textbook fees. And there's institutional models to buy credits to be able to, you know, do that. But building a large language model is a great idea. I'd love to do that. But the what's already out there is blowing my mind. Can I share my screen actually real quick?
Yeah, let me quickly make you
See.
co-host.
I'll just give you an example of a use case for this. Try this. Hopefully, I'm a square peg in a round hole, not a peg with no hole. Let's see. Share screen. So, for example, like, so this is a researcher perspective, and this actually is teaching too, because I do a lot of biohackathons where it's like an experiential approach to getting people excited about solving a problem and from different disciplines and not just doing computer science stuff, but doing like biology stuff and, you know, computer science or whatever needs to happen in it too. But these are two kids that were working with their mother. This is the Drake Radin Foundation. And these kids have, if they don't have any intervention, they have hundreds of seizures a day. Most children with this disease, NKH, they have too much glycine in their brains and it causes seizures. But the ways they treat it, there's no real way to treat it. So the mother has come across a way to treat them with cinnamon. And so a cinnamon extract stops their seizures. And so their children have lived a long time, longer than they would have expected to be living. It's a very sad story. But so we've had hackathons to get together to try to understand what's happening, how is cinnamon interacting with the body, right? And trying to do like a nutraceutical, you know, type approach to understanding, just trying to do biochemistry or whatever, computational biochemistry to see what's happening. One of the things we're doing now is we have the ability to upload. I have like 10 researchers that I was able to pull together, some, you know, professionals, some citizen scientists, and they found a bunch of scoured the literature and found some good stuff. And we have uploaded that into our own compendium. We can ask questions of that using our generative AI teaching assistant, research assistant. And then if the questions aren't answered, it goes off to the large language model, and we're still leveraging corrected answers from Chat GPT models. And so this is giving me some pretty focused answers that for just by doing a little bit of research and pulling together what I need. So I don't even need a large language model to make a lot of progress in my research right now, because I can make a satellite model that lays on top of a large language model. And again, the ChatGPT was not designed to understand these, you know, rare childhood diseases. You know, some other models that we can point to other models as they come online to be able to do that research. So like, I would hate to go and get a grant, spend all that money to build a model, you know, locally at Clemson or in the cloud when I've already got what I need. It's kind of like, do I need internet too to transfer data at 400 gigabits per second if 1 gigabit's transferring my data fine? How's that for a radical statement?
I guess and there's several other members on the call. So I'm wondering, like, what are other use cases that folks are seeing on their campus, like especially when it comes to generative AI? From research point of view, I think like direct use of existing tools is one use case, but then are people actually seeing having um, generative, like large language models built locally and getting deployed?
So I'll just chime in. I don't have an answer to your question, I mean, specifically, but I have to leave at past. And so I just wanted to mention that we are actually working on some large language models, and that we've developed some. We're seeing faculty develop them. There's also been a lot of you know, a lot of buzz around some of the products coming out from Microsoft, like Copilot, because we subscribe to Microsoft products. And so we're trying to figure out, in terms of, from an institutional perspective, and I'm for those who don't know me, I'm from Northwestern. We're trying to figure out, when is it responsible to be using such tools? From a security perspective, that is priority number one. But there are all of these different departments that are trying to come up with courses, curriculum, even names in their departments that include AI or data science, in all of these research centers that are popping up or rebranding. And so our vice president for research has actually very quickly and aggressively, in a good way, aggressively brought several high profile or some, AI or data science focused faculty department chairs together in a steering committee and a working group. They meet a couple hours a week, every week. They're meeting for 2 hours. And so what we're trying to do is create a university-wide, more focused vision in these areas to provide more guidance. The other thing that we're struggling with is when these products like OpenAI or Copilot become available to folks at Northwestern, whether it's students, faculty, whatever, who is supporting them? Because our Microsoft folks, they've been supporting more Teams, email, those kinds of things, and this is a totally different beast. And so for research support, we need to make sure that we understand the research use cases, where our teaching and learning folks are more concerned about how it affects teaching and learning. And so it's really difficult to kind of get your hands around, but we're working on it from several different institution-wide angles, as well as pockets in IT.
That's exactly. I mean, I've been on the road show a lot, and like at Clemson, for example, we've had our AI summits, and trying to get people together. And that was focused on. It's always interesting to me to focus on education, and like I teach and I do research, and to me they're the same thing, because we're doing research while I'm teaching. But yeah, so there's people like trying to plan this out. We have this product that we have we got our heck vats, and we have everything's safe, and people can personalize it and have their own body of knowledge. I've noticed one of the biggest problems I've noticed are concerns people have is like, I've got my bit of data that, or my IP that I teach with or I do research with. You can load that up into its own little bubble and be able to analyze stuff and keep it separate from the large language model, so it's not going to that. So we've already worked out a lot of these things, but and like I said, this PRIA is the name. I think it's through Praxis AI. It's being piloted at many universities. It's being used extensively at Alabama State University through lots of professors for teaching and research purposes. It's great. I use it. It's awesome. But one thing I've noticed is that that I think is very important is I was on an AI summit at Clemson, and there was one, I guess, cheeky professor, I wish it was me, who said at the end of the thing to the student panel, we had these like, genius students up there, I'm not worthy kind of people. And the professor said, well, so you're using ChatGPT for all of these things, right? And so how much of the ability to do prompt engineering and, use this properly and ethics and all that kind of stuff, did you learn at the university? And they said, the answers were between 99 or 1% and 0. We're taught at the university. So the students are out there right now paying their own money to go to ChatGPT in the Wild West and doing whatever they want to do with it. And there's cheaters are cheaters. I don't want to go there, but like not knowing if the answers are correct, they're just going and getting these things, right? And so while we're talking, which we have to talk about this, the students are using and they're not getting guidance I'm sure at most universities, right? Because it's so new. And so I guess the same thing probably happened with Google search, right? Like all of a sudden it's on and everybody's using it and there's, no guidance with it. So one of the things I do is I actively teach prompt engineering to tell people how to answer these questions. And I've seen the power of it.
Yeah, I mean, I've heard variations on this from language teachers, recognizing that, they're not going to keep kids from using it. So then, how do they teach them to use it in a way that doesn't compromise their learning, and actually, gets them to do something more interesting? So I think that's, certainly a whole area, especially for instructors. I'm curious from some of the other folks on the call who are involved in planning and policy and things like that for their institutions, what similar challenges they're seeing, everything from infrastructure to policy and planning, just to hear from some other folks at other universities.
I've seen, to answer Bob's question in the chat, I've seen other institutions that have AI policies posted. I know University of Michigan does. I think if you just Google like University of Michigan AI policy, it comes up and they have a whole report and document. Penn State is currently working on a policy with our general counsel and information security, I think for the business side and for like kind of research and administration side. So thinking about like, can we write a proposal using AI? And so I think that is interesting, but there are certainly a lot of use cases to consider. And I don't think the universities like at a central level can consider all of those. Yeah, so it's kind of giving some type of high level guidance, like, be smart when you're using it. Like, what does that mean? Just like Alex is saying, like teaching prompt engineering, like I call it advanced Googling, really. It's just like my background's in counseling, so I'm trained to ask questions and assessment. So it is interesting. And I would love to hear from others too, what their institutions are doing.
Yeah, since I put that question in there, I figured I should probably offer. I mean, it is a great point, Ashley, and I'm very curious to see how other universities have come out on this. Harvard, I mean, there's been multiple attempts at policies on use of AI, especially generative AI in the classroom and for research. And I think the biggest concern that Jackie had alluded to is around security. And specifically, I think more data security than necessarily system security, as I alluded to in the chat. And what has been interesting is there has been some movement forward. I usually get our group is not, so Research Computing Services is not in IT. So we oftentimes get pulled into IT discussions around services and service offerings. And there was this whole discussion around surveying the use of generative AI tools for current, software offerings and future. And I'm like, oh, I don't know the product, roadmap for X tool and whether they're going to be using, generative AI. So I think they're trying to understand the scope of where this is going, and especially around how persons used tools with AI capabilities built into them, and does this potentially open up loopholes or problems for work, either in the academic side, the research side, and the pedagogy side, and so I think that struggling is probably a really good way to talk about it. I think on the flip side for Alex, and having been in Alex's shoes for many years, a biology researcher, and knowing that the capabilities of how it could really advance one's research program, it's also, the university is trying to do, I think, good due diligence around not necessarily limiting, but also at the same time trying to afford opportunities. But what we're seeing is that the opportunities aren't happening fast enough. I had a doc student say, "Oh, he heard about, Harvard's there's some, enterprise license for ChatGPT, and as far as I know, there's only a couple of accounts, and they've been doled out to strategic places." And so, we're having to say, use your research funds or personal funds or whatever, but you can't do anything that has, involves secure data. So it's like, oh, do it on your own, but don't do it this way. And so, I think we're in this middle ground of trying to work this out, and also with the area being so new that there's a lot of struggles. I think the other thing, early on in the discussions, I like where things were going. I do like also, Alex, that you brought up the fact that building models, we kind of don't have to do that anymore. And so I think it's interesting to sort of classify some of the questions or problems into, de novo problems around building models, generating models, these sorts of things. And then where we are right now in this area where we're sort of fine tuning or using, how did you put it, Alex? Compendium of information for.
Yes, a satellite piece of that doesn't mean not integrated the model. I call it satellite.
Right,
satellite GPT.
Right. Yeah. Yeah. And fine tuning and the challenges around that as well.
I feel like I'm in a radical mood today. So I'm a researcher, and I believe there's a thing called open science that people seem to have forgotten about. Like, we're supposed to be putting out information so everybody can use it, and there is no security when I publish papers, and I make sure everything's open source so anybody around the planet can read it. And so nobody's going to, I guess they'd have to fire me before I'd stop me from using this amazing tool to be able to find information and solve problems and discover and teach with these tools, right? And that when the campus or the university is involved, all this security stuff, we've got all that worked out with this, right? Where it's all compliant and everything, and it gives great answers. And so we just need to dive. We've got to dive in to use this. We've got massive problems that are affecting our species, and we need some solutions. And if we, don't dive into this, I mean, to me, this is like Renaissance 4.0. Like, we skipped Renaissance 2 and 3 and went straight to 4 with this generative AI stuff. It's blown me. It's made me. I saw my ceiling as a teacher and a researcher, like in 2022, and now I don't see it. I don't see that ceiling with these tools. Every one of my students in my class has an associate professor level geneticist, bioinformatician, computer scientist in their pocket through Priya, through our thing. And she is, helping them. Able to teach people code that are, there's a lot of biologists who are like intimidated by coding and stuff. And I've learned how to get people over that. I can get them over it so much faster now and accelerating the training process. So, every semester of not implementing a solution is a semester wasted, in my opinion. And I say that with everybody. I'm not trying to, across the planet, in high schools, everywhere. Everybody should have these tools.
So, Alex, you're painting a a fairly rosy picture in terms of the ability to deploy this, which is great. Had also been hearing from a lot of folks in the community about tremendous struggles with putting together the resources in a central compute facility. Maybe it's not even building large language models, but just taking advantage of some of these. And I'm curious, is that a red herring, or did I misinterpret that? Hearing from the people who are actually trying to run centers, I know how expensive these things are getting, and the lead times are ridiculous on them. So, aside from Alex, what's the story at other institutions in terms of literally just providing the resources and planning for that in order to support folks trying to use this stuff?
I can chime in a little bit. We're doing a few things at OSC. One, we're in the middle of we'll be deploying a system over the summer. So the purchase was just recently announced. And so when looking at how many GPUs to put on the system, right? We know there's high demand. The price was also really, really high, right? We're putting in some H100s. Just a real big jump in pricing, so that changes, the overall amount of resources we can provide to our researchers. So I think, people have to take that into account, right? That costs are very high. We've had discussions about support to go along with those GPUs. And also very, very expensive for the type of GPUs we bought, the pricing for the support package. And so I think those are real hurdles. They can be real hurdles to people, right? And trying to make the trade-off between general purpose CPUs and GPUs, given the pricing. I think the other thing is that the deployment model for AI models are kind of cloud native, right? They're client server systems, and our traditional way of making compute available in with things like Slurm. There's a mismatch there. So looking at, where do we have to have more cloud-like interface, virtual systems available to clients? How do we help them use those systems? Because not everyone wants to build their cloud deployment from scratch. We don't have a lot of staff to become cloud experts and build all those, cloud deployments. And then, if a researcher is using a big model that consumes a GPU or multiple GPU, and they want to have it available, but they're not doing queries 24/7, right? And so how do you take those really expensive resources and allow deployments of models that where you're using that hardware effectively? So that's what we're kind of looking into right now. How do we kind of support it with things like NVIDIA's Triton or something, and do it in a way that uses our resources kind of wisely, and then maintains, why do we not deploy servers on our HPC systems? Because we don't want just anybody being able to connect, and we want to control access to our systems, right, from a security standpoint. So there's that kind of, again, fitting this kind of deployment in our model that meets our policy requirements. And so I'll stop there. I don't know who else is grappling with these things, but
Can I answer a question about that? So, like the H100s, right? So first of all, like if you can get one, right? They're expensive, but you got to even see if you can get one. So if you build the infrastructure and then you start building large language models, and that's that's a very critical. I mean, I think this is the future of research computing, right? This is a big part of it. But that's going to take a long time and a lot of money, and this is definitely something for elite institutions. Smaller institutions will never be able to do that. They can barely get enough number crunch or CVUs together to crunch a few numbers, right? But like so that is a very important policy for developing large language models and access and all that kind of stuff. But what about like right now? Like right now, I am accelerating my research and my learning as a professor. Just one data point, but there are other people using this thing that's it integrates with Canvas and they just use it right in their existing courses and stuff like that. And so it's great. It's being used right now, and there's no IT infrastructure with this. It's a credit thing to go out, pay the third-party providers to be able to, access models and stuff like that. So isn't there like at least two different policy phases, right? I mean, one is building large language models and one's just using what already exists.
I think the challenge with using what's out there is again, procuring cloud services, right, that have AI behind them. For example, we couldn't get Grammarly approved at OSU, right, because of privacy concerns. So
Right.
there's procuring subscriptions to things also has a long lead time because they have to go through both accessibility review and legal
Totally get it.
review.
Yeah.
Well, it's
So-
interesting. Oh, sorry, Karen, go ahead.
That's all. I just want to say it's maybe faster than buying hardware and deploying hardware, but it's still not a fast process unless an individual does it and ignores the legal procurement steps that are
Right,
going
and then they end up being out of compliance, and at some point somebody comes after them. And this is something, for a long time now, we've seen at least some level of conflict or tension, I should say, between the folks for whom jobs fit really well into a cluster, whether it's a campus cluster or national clusters, and folks who really need cloud infrastructure as an architecture. And that ranges from, as Karen brought up, the skill to help them. Because Alex, you mentioned you can just go get it as infrastructure, but infrastructure isn't just hardware, right? And it's often people. You've had a chance, Alex, to develop a bit of sophistication around cloud architecture. You've been using it for a while. For a lot of people, get into it and they're overwhelmed by the set of services that are involved, and they get completely blown away by the first bill when they realize just how many services they signed up for.
Sure.
And that's aside from the fact that very few institutions at this point have figured out how to do an overhead exemption for cloud services. And that puts them at a real cost disadvantage with respect to hardware when they're trying to figure out how to use grant money for these things. And so, I'm wondering if maybe AI is going to be the app that pushes hard enough on the cloud side of things to get more movement in that direction. I know there are more institutions that are exploring the idea of an overhead exemption so that services can be competitive with hardware, but that's a really tough thing at a lot of places. And that's another whole aspect of policy. And I'm wondering how many people are hearing that discussion at their institutions around, okay, well, if we have to move to the cloud to use this stuff, then we have to make it more reasonable and affordable, which includes having people to help researchers use this stuff and the financial models to make it more competitive with buying hardware.
Well, the other aspect that I have encountered at Penn State is we still have open source model out there that can at least compete with the likes of ChatGPT. At some point, if there are none, then we will be forced to go towards subscription model, and we will not be able to do our own unless our faculty comes out and builds their own from grounds up, and that's much harder to do. And as Alex mentioned and several others mentioned, if it's already there, we can just use it. So I think the attractiveness of this subscription model is a lot more at this stage. Going forward, I'm curious to hear what other challenges people are hearing about in supporting these large language models. Yeah, Colin, please go ahead.
One of the things that we're considering at Ohio State is, especially for things where no one is set up to be a ratepayer for commercial cloud, either because the variances around what it's going to cost are so huge, or we've got people who want to they want to get a proof of concept underway so they can submit a competitive proposal that demonstrated they got the proof of concept, right? There's that sort of bootstrapping problem. If you've got an academic medical center that has a large volume of on-prem hardware still, you might consider looking at whether stuff that's laying fallow outside of certain business hours might be a candidate for Slurm. We haven't executed this, we're still exploring, but you might look at some of your on-prem infrastructure that is underutilized outside of certain hours, and could you be capitalizing on that? It's clearly that doesn't solve all problems, but I think one of the places it's hardest to serve is you don't want people to go sort of direct to commercial cloud, kick off a job, kick off a model that never converges, come back Monday morning and learn that you've burned through thousands and thousands of dollars. It's nice to have a safer space where you're paying for power and cooling. You can put your own guardrails around it, and you're also showing that you're sort of extracting the most value out of that existing on-prem investment. We also found that basically, don't start throwing things, but we found that there was an operational infrastructure project that overbought A100s. And so, depending on the part of the enterprise you're talking to, that is either incredible or, oh yeah, that's a thing that happens. So poking around, turning over the couch cushions, and seeing where you've got potentially underutilized resources, and also how close to 24/7 utilization can you get. I think if you're going to have a multi-part strategy, that could be part of your strategy.
Well, I know there are a lot of places that are trying to deploy local clouds to manage the cost more effectively. I'm not sure how much of a challenge it would be to do a solution like what Alex is talking about on a local cloud. I suspect there's a bunch of licensing issues that get out of hand.
Can I ask a question? So like most places are Canvas shops, right? Like most people have Canvas, like to for their online education. That's a cloud service where you can purchase other services, right? And like Priya's there. I mean, I'm selling too, right? Telling you right now that this exists. But like, why would you want to then? So if people are happy with Canvas, why would you want to then go and make a homegrown Canvas? Like if a service already exists in the cloud and you're paying, subscription fees or whatever it is to Canvas, like why is this different? Like why would you have to have your large language model be local, especially when it's probably way more expensive to run than an online learning tool? Just as an example of a cloud-based service.
Yeah, Karen, go ahead, please.
Yeah, I mean, my response would be that for, technology for education is supported university-wide, and faculty in a wide range of departments can all use Canvas, right? It meets their needs.
Yeah.
But when we go to research models, everyone's going to want a different model, right? If we look at simulation software, right? I'll pick an area where we have a lot of software because it's expensive to run. Quantum chemistry. You could say, well, you just need one quantum chemistry package. No, we have 4 or 5 different softwares there, right? If we talk about AI models, they're going to become very specialized, and how many we're going to have to deploy. We're going to have to deploy a lot of them, right?
Well, and to the point that a number of folks are bringing up, there's a fair amount of data that they can't put into some sort of a public service like that won't get past policy.
But like we have the ability to have your own in-house collection of data that enhances, in a model. You can go to any large language model. We're leveraging ChatGPT right now, but we'd love to have something open source for language engine stuff. But I mean, we solved that problem. It's because everybody we've talked to wants to have their faculty want to have control over their IP from what they're teaching, and they want to have it separate from the large language model. So we already have that. We have all the compliance. We've done all that. It's all there. But like, I mean, I just, again, like having, like, if you need lots of specialized large language models, hosting those in-house doesn't seem like it's going to be cost effective. It's going to have to be out in a cloud somewhere, and you're paying some access fee or whatever. So you're APIing into it. That's exactly, we use API, we use MongoDB, OpenAI, a couple other services, lump it together into a credit pool, and the credits don't run out in a semester. The students don't pay that much money, and it works great.
And I think there could be other couple criteria, like if you want to consider closed model, Gemini, for example. I don't think they would be deployable on-prem, for example. Right. And the other aspect is obviously how your investment model is funded. CapEx versus OpEx, that's a financial component. Some institutions might not consider operational expense tenable, or if your growth pattern changes, right, they want to do an upfront investment and capitalize on that versus pay as you go.
Yeah, but I think, one of the things that people like about clusters is that anybody can get on for free at the beginning while they're still playing and learning. At least in many institutions, they have a model like that. And convincing folks that, okay, we have to take a big chunk of the money that we've traditionally devoted to our cluster and buy a bunch of credits in the cloud and distribute them. And how do we distribute them equitably and with control so the one person can't burn through the whole credit pool and things like that? Yes, that might be the right model, but it'll take a little while to get that ironed out and deployed.
We've been deploying that at multiple institutions for over a year now.
So who pays for the credits, Alex?
We're a lot of the pilots we're doing it gratis right now. So it's through Canvas. It's through the Canvas marketplace to get the access into this.
I think that's a different use case because that's more from student and teaching point of view. For research, there's a lot more variability, shorter durations, longer durations, and so on. So there's difference in course-based access versus research is what I feel that there's a difference that people are facing here.
I'm a researcher and an educator. I've been doing it I've teaching for 20 and doing research for 30. And I use the exact same AI for both purposes. It works for both things. And I use it to start off legal documents and stuff like that too, right? But it works great. I love it. I'm selling it. I have bias, but also just all I care about is people learning discovering things and learning how to discover things. And it's like it's mind blowing how much better it is. And it's there. It's great. It's HECVAT enabled.
Yeah, and I think it sounds like you've got a really compelling service offering with Priya. It also sounds like it doesn't fit everybody's needs, and I think that some of it is figuring out, okay, what variation on what you're doing can fit the other needs, and where else are we going to start seeing some of the challenges? So anyway, we're pretty much at time. Thank you very much, Alex, for coming and joining us today, and the other folks who've spoken up. It's clearly there's a lot more to figure out on this stuff, but it sounds like there's some really interesting early progress that's being made with some of these things. That I also appreciate all the chat comments in the chat pointing to some policy documents as different institutions are trying to figure this out. We'll gather those up and put them in the notes as well. Interesting discussion. Thanks, everybody.
Thanks, everyone.
Thank you all.
Take care.